4, which is powers with positive rational exponents. So before we start, we are going to just review some of the exponent laws we learned back in grade 9 and 10. So let's have a look down here, and we're going to evaluate some of these. The first one is 3 squared times 3. Now, this just a quick reminder, so the little 2 here is called the exponent, and it indicates how many times you want to multiply the base, which in this case is 3. So, and then if there's no exponent written there, there actually technically is. We just, if it's a 1, sometimes we don't write the 1, but there is always an exponent on every number. And if you don't see it, it's just a 1. So in this example here, we're multiplying 2 powers together, and they both have a base of 3. So when you're multiplying 2 powers together, you get to add the exponents. So in this case, it would be 2 plus 1. And then that would be 3. So our base is 3, our exponent is 3, so that means we want to multiply the number 3 times. 3 times 3 times 3 is 27. So that would be 27. The reason you want to apply this rule and not just evaluate them separately is because it usually is a lot less work. So let's look at the next example here. We're multiplying 2 powers with the same base, which is 7. And the exponents are -8 and +8. So if we use that same law, which says we can add -8 and 8 together, this would be 7 to the power of -8 plus 8, which is 0. And that's a lot easier to evaluate than doing them separately. So that would be 1. So anything to the power of 0 is 1. Okay, the next one. We have 2 powers and they are being divided. And they do have the same base. So the second exponent law that you would have learned back in grade 9 is that when you're dividing 2 powers with the same base, you get to subtract the exponents. So we're going to subtract 7 minus 5, and we'll get 2. And 4 squared is 16. 4 times 4 is 16. Okay. And then the third exponent law you would have learned is called power of a power law. This one's going to be really important in today's lesson. So when you have 2 exponents kind of back to back, you get to multiply them. So 3 times 2 is 6. And 2 to the power of 6, if you multiply 6 2's together, you get 64. Okay, and the next one, we would apply the same rule. We have 2 exponents back to back. So we're using the power of a power law. So we multiply those together, and we would get -2. And this is a little reminder, last year in grade 10, you should have learned about negative exponents, but it might have been a while since we did that. So I'll just remind you. So in math, a negative sign doesn't always indicate a negative answer. What a negative sign typically indicates is that you want to do the opposite thing that you would do compared to the positive situation. So 3 squared, I'll just write this down here. 3 squared means we multiply 3 twice. So it would be 9. So what 3 to the power of -2 means is instead of multiplying, we want to do the opposite thing twice. And the opposite of multiplying twice is dividing twice. So it's actually the same as dividing by 3 twice, like this. So it'd be 1/9. So you don't get a negative answer when you have a negative exponent. It just means instead of multiplying twice, you want to divide twice, or however many times the exponent's telling you. And the last little example here is a reminder of what to do when you have a fraction that you're taking an exponent of. So 5/4 to the power of 3. What you would do here is multiply 5 3 times and multiply 4 3 times. So this would be 5 times 5 times 5, which is 125, and 4 times 4 times 4, which is 64. Not just the top and not just the bottom, but both. Okay, so that was our little review of fractions. And because in this chapter we've been dealing with rational numbers, today we're going to be talking about what happens when you have rational exponents. So what happens when these exponents are fractions or decimals instead of whole numbers or integers like they are in these examples here. So we're going to construct our understanding in these tables here. We're going to evaluate a bunch of numbers to the power of 1/2, and then we're going to take the power of 1/3 in this table. And what we'll see is it's actually similar to taking a square root or a cube root. Okay. I'm going to leave the number 1 out for now just because it's kind of a redundant case. We'll start with 4. So now 4, in the previous lesson, we learned about how to break a number up into its prime numbers. So 4 is the same as 2 times 2, right? So if you want to go halfway to 4, so the 4 to the power of half, another way of thinking of it is like exponents are talking about multiplying, right? So we want to get halfway to 4 in sort of a multiplying sense. So to get to 4, we do 2 times 2. So halfway there would be half of those 2's. So it would be just 2. Another way to think of it is it's the exact same thing as asking what's the square root of 4? What's halfway to 4? Or what times what is 4? So you just take half of those 2's. So 9 is similar. 9, if you break it into its prime number factorization, it's 3 times 3. So half of 9 would be half of those 3's. So 9 to the power of half is 3. Another way to think of it is it's the same as taking the square root of 9. Notice I'm writing the little 2 here. You don't have to write it, but it helps me remember because the little 2 is consistent there. 16, if you break it up into its prime factorization, it's 2 times 2 times 2 times 2. So if we're doing 16 to the power of half, we're going to get halfway there. So we want to take half of those 2's. So that would be 2 times 2, which is 4. Another way to think of it, again, is it's the same as taking the square root of 16. So what times what is 16? Either way you kind of like to think about it, it is totally fine. So if you like to think of it as breaking it up and taking half of the number, that's great. If you like to think of it as a square root, that's also cool. So 25 we can write as 5 times 5. So we want to get halfway there. So we would just take 1/2 of those 5. 36, if you did the prime factorization, it would be 2 times 2 times 3 times 3. So we want to take half of it. So 1 of the 2's and 1 of the 3's. So it would be 6. Another way to think of it is it's the square root, oops, what's going on here? Square root of 36. Okay, let's talk about power of 1/3 over here. So I'm going to break these numbers the same way and kind of explain it in the same way. Oh yeah, we've got to do 1. So 1 is kind of redundant. 1 times 1 is 1, so we take half of the 1's. 1 to the power of any number is still 1. So that one's kind of boring. Same with this one here. 1 to the power of any number is still 1. But let's look at 8. 8, if I break it up into its prime factorization, it's 2 times 2 times 2. So if I'm taking 8 to the 1/3, what I want to do is get 1/3 of the way to 8 in a multiplying kind of way. So 1/3 of the way to 8 would be 1/3 of these 2's. So it would just be simply 2. Another way to think of it is it's the same as asking what's the cube root of 8? What times what is 8? And notice this 3 matches 3 in the power. So those two mean the exact same thing. 8 to the power of 1/3 is the same as the cube root of 8. 27, I'll just do a couple more and then you can finish it off. It's 3 times 3 times 3, so 27 to the 1/3 is asking what's 1/3 of the way to 27? Well, it would be 1 of these 3's. It's the same as asking what's the cube root of 27. I'll do one more, 64. If we broke that into its prime factorization, it would be 6 2's. 5, 6. So 64 to the 1/3 means what's 1/3 of the way to 64? So 1/3 of these 2's would be 2 of them. So that would be 4. Another way of asking that is what's the cube root of 64? It's the same answer, 4. Okay, this one would be 5 and this one would be 6. Okay, so now we kind of understand asking what the power of 1/2 is the same as asking what the square root is. And asking power of 1/3 is the same as asking what's 1/3 of the ways in the number or what's the cube root of that number. Okay. And on the next page are just all those exponents laws I mentioned again that you guys learned hopefully in grade 8 and grade 9 and grade 10. The one that's going to come up the most today is the power of a power law. So when you have two powers in a row, you can multiply them together. Okay, so for example, here they show 5 to the power of 6, and that's the power of 2. You can multiply the 6 and 2 together to make 12. Okay, so let's keep going. You can read through these if you need a little reminder. We're going to jump right into the first example. It says, write each power as a radical. That means write each power using a square root or cube root, and then evaluate it. Okay, so we'll go through each one. I'm going to do, yeah, I'll do each one with you. 25 to the half. So remember that was asking like what's halfway to 25. Another way of thinking of that is what's the square root of 25? So notice the 2 matches the 2 here. It's asking what times what is 25. So halfway to 25 would be 5. Okay. And note, you don't have to put the little 2. I just like to put it, but you don't have to. If it's a 3, 4, or 5 or larger, then you do have to put it, but the 2 is just assumed if you leave it blank. Okay, next one, negative 32 to the power of 1/5. That means what's 1/5 of the way to negative 32 if you're multiplying? So another way of asking that is what's the 5th root of negative 32? So what times what times what times what times what is 5th negative 32? So if you multiply 5 2's together, you get 32. So the answer to this would be negative 2. And notice again here, this 5 matches this. So the root here, the index of the root matches the denominator of the fractional power. Okay, you can go ahead and pause and try the next two, or you can do them with me. 64 over 27 to the 1/3. What this would be equivalent to is what's 1/3 of the way to 64 and 1/3 of the way to 27, or what's the cube root of 64 over 27? So 4 times 4 times 4 is 64. So the cube root of 64 would be 4. And the cube root of 27 would be 3. Okay, and then finally, this one I'm doing because I want to mention that anytime you see a decimal in this section, turn it into a fraction because it's much easier to understand fractional powers than it is to understand decimal powers. So 0.5 is the same as 1/2. If you have trouble doing this, you can ask me for some extra help, but also your calculator likely has a button that changes decimals into fractions for you. So it's a little cheat. If you don't know where that button is, let me know and I will help you find it. But if you have a normal scientific calculator, it should have that button. So 0.5 is the same as 1/2. And 64 to the half is the same. Remember, it's asking what's the square root of 64. So what times what is 64, or what's halfway to 64 when you're multiplying? And that would be 8. Okay, so that's how to evaluate fractional powers. And notice every single one of these, I'm going to highlight something here. Every single one of these had a 1 as the numerator. So later on in this lesson, we're going to deal with questions where that numerator isn't 1. But when the numerator is 1, all you do is convert it to a radical and then evaluate. We're going to practice going backwards now. If you're given a radical, you could also write it as a fractional power. So we're going to do that here. We're just going to evaluate these 3. So the 4th root of 5.8, and it doesn't ask us to actually evaluate it. It just says write each entire or mixed radical as a power. And so that would be 5.8 to the power of 1/4. So notice the 4 matches the 4. And again, we don't have to evaluate. The question doesn't ask us to. It would be a irrational number, so it would be a decimal. Cube root of 20 over 9, that would be the same as asking what's 20 over 9 to the power of 1/3. Again, this index here matches the denominator in the power. And last one here, this one's a mixed radical. So in order to change it, I would have to write it as an entire radical first. That goes back to the last lesson. So if you need a quick review on that, you need to head back to the last lesson, but I'll do it quickly here. 2 is the same as the cube root of 8. And then remember, I can put these together under one roof here. So 8 times 5 is 40. And then the cube root of 40, we can write as 40 to the power of 1/3. Okay, good. Let's go on to example 3. So example 3 and example 4 are actually going to ask us the exact same thing. We're going to be evaluating fractional powers where this numerator is not 1. So that highlighted number in the green is not going to be 1. And it's going to be 2 different methods for doing it. You need to understand that there is 2 methods and how to do both, but you can definitely have a preference. And when the question doesn't tell you which one to use, you can decide whatever one you like better. So let's go to question 3 first. It says write each power as a radical. So we're going to change it to a root and then evaluate it. Okay, so because there's a lot of space up here and not so much space there, I'm going to use this blank space. So I'm going to flip back in my book, make sure I'm in the right spot. Okay, so this is 3a, and we're evaluating -8 to the power of 2/3. And I'm just going to double check everything's working. Okay, great. Okay, so what this does is, so when the numerator of your fraction is not a 1, what you need to do is think of this number, 2/3. You can break it into 2 parts. So 2/3 is the same as 2 times 1/3. Those are the same. 2 times 1/3 is 2/3. So what we're going to do is break this power into 2 parts and evaluate one part first and the next part second. Okay, so we're going to use that power of a power law to do this. So we'd have -8 to the power of 2, and then all of that to the power of 1/3. So notice that 2 times 1/3 is 2/3. Those are the same number. 2 times 1/3, oops. 2 times 1/3 is 2/3, so I'm allowed to do this. So we're going to evaluate the middle part first and then the outside. And remember, power of 1/3 just means cube root. So this is the same as cube root of -8 squared. So we're going to evaluate this middle part first and then the cube root second. So -8 squared, that means -8 times -8. This would be the same as 64. And the cube root of 64 asks what times what is 64, or what's 1/3 of the way to 64. So that would be 4. So again, we split our number into 2 parts to separate it. The 1/3, you can write it as a cube root. You evaluate the middle first and then the outside second. Let's try it with part B. Actually, you can try part B on your own. I'll do C. So we have 100 to the power of 2.5. So again, I mentioned in one of the section, you want to change it into a fraction because we can much easier understand fractions rather than decimals. So 2.5 is the same as 5/2. Those are the same number, and we're going to split 5/2 up. 5/2 is 5 times 1/2. Okay, so I'm going to split the 5 and 1/2 here. So I'll have 100 to the power of 5 all to the power of 1/2. So 5 times 1/2 is 5/2. Okay, so, and remember 1/2 is the same as a square root. So this is the same as square root of 100 to the power of 5. So I'll evaluate this middle part first and then do the square root second. So 100 to the power of 5, I'm just going to multiply the number of zeros I already have by 5. So I'm going to end up with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how powers of 10 and 100 work. You just add up the zeros. And then the square root of 1 with 10 zeros, you cut the number of zeros in half. So that would be 1, 2, 3, 4, 5 zeros, 100,000. So that's example 3. So again, what we did was we split up our fraction into 2 parts, the whole number and then the fraction with the 1 on the top. And then we evaluated the inside first and the outside second. We're going to do the same thing in example 4, except we're going to switch these around. So instead of going 5 times 1/2, we'll do 1/2 times 5. I prefer the example 4 method better just because you're dealing with smaller numbers. If you notice in this example here, we had this huge one with 10 zeros. You wouldn't have that problem if you switched. So we'll see that in example 4. You can scroll to example 4. I'm going to do A and C again. So I'm going to do 4A here above just because there's more space. And 4A is asking us what's negative 128 to the power of 3 over 7. So remember, we're taking 3 over 7 and we're splitting it up into 2 parts. 3 over 7, before we said it's 3 times 1 over 7, but in this case, we're going to do it the other way around. 1 over 7 times 3. We're going to split that into 2 parts, break it up into 2, and evaluate one first and the next part second. So this is the same as asking negative 128 to the power of 1/7, all to the power of 3. Now, 1 over 7, that's asking the 7th root. So this is the same as asking, what's the 7th root of negative 128? And then we're going to have this power of 3 on the outside. So the 7th root of negative 128, we need to ask ourselves, what do I need to multiply 7 times to make it to negative 128? So the answer to that would be 2. You can try it on your calculator. If you multiply 7 2's together, you get 128. So this would be negative 2 to the power of 3. And that's just negative 2 multiplied 3 times, you get negative 8. So something that looks quite complicated, you can actually do without a calculator. And you want to break that into 2 parts. This is different from example 3 because we did the fractional power first and then the whole number power on the outside. Let's do part C. You can do part B if you like on your own. Part C. So I mentioned before, if you have a decimal, you should change it to a fraction. So 2.5 is the same as 5 over 2. Okay, I'm going to just zoom in so we can see a little bit better. Here we go. So 5 over 2, we're going to break it up. So 5 over 2 is the same as 1/2 times 5. Those are the same thing. So I'm going to take this and break it into 2 parts. And this one is a little bit different from part A. It still has a negative sign, but notice there's no brackets around the negative sign. So that means the power doesn't apply to the negative sign. In the first example we did, there was a negative sign, but it was within the brackets, which means the power applies to it. So when there's no brackets around the negative sign, you want to leave it on the outside. And so what we want to do here is have 81 to the power of 1/2, and that's all to the power of 5. So 1/2 times 5, that's the same as 5/2, so we're allowed to do that. And remember, power of 1/2 is the same as asking the square root. So we're first going to do the square root of 81, and then we're going to put that to the power of 5. So this is square root of 81. We're asking what times what is 81, or what's halfway to 81. So that would be 9. And then we need to evaluate 9 to the power of 5. That's going to be a big number. If I multiply 5 9s together in a row, I get, I'm going to use my calculator for that, this number here. Okay. So just to quickly review the difference between example 3 and example 4, for both of them, we were evaluating fractional powers where the number on the top or the numerator of the power was not 1. And we split that fraction into 2 parts. In example 4, we put the fraction first and then the whole number second. And in example 3, we put the whole number first and then the fraction second. So you can decide which one you like. You should know that both are possible and know how to do both. So either one, when you're doing these kind of questions, explain why. So what that's asking is compare example 3 versus example 4. Which do you like better? You should have a preference, because if you're asked the question, you should know which one you like to better use. I prefer example 4 because you're typically dealing with smaller numbers, because when you take the fractional power first, it actually reduces the number. So like, for example, here, 81 turned into 9. Yeah. And that is it. I will stop recording.